Welcome to Team Kit Switch. I don't know if I need to give you any permissions for sharing or how you would like to begin, but we're very happy to have you join us.
Thank you so much. Yeah, I think I should be able to share my screen. So I'll go ahead and do that. Hi, everyone. My name is Armelle. Super excited to be here with you today. I'm here with my teammates Anusha, Sam, and Candice as well. And I'll just hop right into it. You know, across the world today, there are thousands of new buildings being constructed every single day. And with them, construction techniques have also been evolving with things like more precise measurement devices, virtual design and construction software tools, and methods such as industrialized construction, which we'll be taking a closer look at today. And industrialized construction, or the process of manufacturing buildings components off-site and then assembling them on-site, it's based on this idea that by standardizing parts of the construction process, making them in a factory, the industry can achieve some of the efficiency, accuracy, and scalability of other industries such as car manufacturing. And while it's not necessarily a cure-all to the issues within construction, it definitely does have some interesting positive and particularly sustainability benefits when it comes to enabling buildings to be built with less errors, less waste. But we also have to think of, what of the buildings that we have already built, and what about their sustainability? And to give you a sense, about 80% of the buildings that we'll be using in 2050 have already been built today. And it's almost certain that over time, their exact use will change from what it was originally intended to be. And so instead of demolishing and rebuilding these structures to suit changing needs, one way to approach existing buildings more sustainably is to opt for adaptive reuse. And adaptive reuse is the process of reusing an existing building for a purpose other than what it was originally built for. It's also known as recycling and conversion, and it's an effective strategy for optimizing how useful a building is to its surrounding community, as well as the value and the return of built assets. And so right now you might be wondering, how do the two concepts come together? Where do the benefits of industrialized construction fit in with the benefits of adaptive reuse? And that was exactly the question that brought together our team at KitSwitch. Asking ourselves, how can we leverage industrialized construction methods to facilitate adaptive reuse? Providing a tool for things such as turning underutilized commercial buildings due to the pandemic into affordable housing.
So we at KitSwitch are the system integrator. We sell our prefabricated and energy-efficient kit of parts to property owners and housing developers who wish to convert their space. We work with manufacturers for manufacturing and architects and GCs for permitting and on-site installation. We began by designing a panelized kit of parts to fit within any existing structure. We wanted to develop a product that could be easily installed on-site and can be made to fit in within any existing floor and ceiling to create a fully functional housing unit. And by leveraging industrialized construction, we hope to streamline the adaptive reuse process and facilitate continuous improvement of any individual component. We found that the key component of converting commercial buildings is the kitchen and bathroom wall system. It is both complex and repeatable, so it would be a good fit for offsite manufacturing. We projected that the prefabrication of this component would reduce the construction time by up to 70% and cost by at least 30%. And in addition to this reduction in construction time and cost, we also anticipate a significant reduction in design time. By using a standardized kit of parts system, we can create a spatial and energy optimized housing layout using 3D modeling tools. So the first challenge that we faced was how do we solve this problem of adding multiple kitchens and bathrooms to a floor that typically has only one? We addressed this by placing the kitchen and bathroom close to the existing corridor. Thus, we try to simplify the mechanical, electrical, and plumbing distribution network. Next, we wanted to simplify the panel installation and future maintenance access. So each housing unit would have one set of kitchen and bathroom wall panels located adjacent to the double-loaded corridor. We are sizing these panels to make sure that they can fit within any standard elevator shaft and also can be installed by just 1 to 2 laborers. And given the higher slab-to-slab height in commercial and office buildings, the MEP distribution would run in ceilings and through the corridor, which then connects to our electrical and plumbing integrated wall system. This makes it easier to pump hot and cold water from the existing core and down to respective floors and through the ceiling. And by placing the kitchen and bathroom close to the corridor would mean that we can easily leverage natural daylighting and ventilation for living and bedroom spaces. Thus, we would place them close to the facade and leverage the passive solar design strategies. And as a result of this, we can reduce energy consumption and plug loads throughout each housing unit.
Our solution relies on collaborative partnerships with cities, neighboring communities, and labor unions. So for cities, we help provide more urban infill housing through reclaimed properties. For neighboring communities, we reduce the impact of noise and dust pollution due to offsite manufacturing. And because we are incorporating offsite manufacturing, we include union trade labor at both on-site work and for offsite components. Now, this approach is also sustainable. Adaptive reuse outperforms demolition and new construction, which takes up to 70 years to recoup the CO2 equivalent difference. Additionally, prefabrication methods have been found to be less carbon intensive and more cost effective than traditional methods due to less labor and more efficient manufacturing processes. This helps especially when it comes to more complex components, such as like the bathroom and the kitchen system that Anusha detailed earlier. By standardizing the components within a wall panel, sourcing sustainable materials and making the panels disassemblable, a wall's lifespan is no longer limited by its weakest link. And instead, individual materials can be recycled or reused in a circular production model, which saves on waste, emissions, and costs.
Okay, so now that you got a sense of what our product is, I'll take you through the process flow of one project. As you can imagine, performing industrialized construction within existing structures comes with a lot of complexities because of varying existing floor plans. So one of the main challenges of our concept is where do we want to draw the boundary between what is done on-site and what's done off-site. Therefore, an important part of it is our information production system, you see in red on this slide. It starts on-site. We are working with LiDAR scanning companies to take precise measurements in the building. Then an as-built model is built on Revit. And finally, our unit design and floor layout are customized using digital tools available to us in the Autodesk suite. And so to link it back to what my teammates were presenting, we standardized key components of our kit of parts in order to streamline this process. This standardized unit design that's on the top left of our slide feeds into our information production system and allows for a parallel process with permitting and manufacturing. According to our preliminary product system model, we estimated that a final throughput of around 5 units could be assembled in under a week. And so overall, we thought through the 8 concepts of industrialized construction and strategically positioned ourselves around 4 specific ones that I want to highlight. The first one is customer and market focus. We target adaptive reuse and affordable housing, hoping to become a reference in this specific market. Then we leverage intelligent construction techniques such as LiDAR scanning, BIM and parametric modeling, as well as life cycle quality monitoring of our panels. The third one is logistics, because our concept requires a strong supply chain integration from manufacturing up to maintenance during the use of the panels. And the fourth one is long-term relations, which is key to our concept. First, we work with city officials and labor unions to ensure the approval of our projects. Second, we decided to target housing developers to get a strong customer base and recurring projects. And finally, we have pre-selected partners to ensure the reliability of our supply chain.
So now that you have a sense of, what is this intersection of industrialized construction, adaptive reuse that we've been working on, I'd like to talk a bit more about the meta process of entrepreneurship. This outlines kind of a version of a step-by-step process, which there isn't necessarily a step-by-step when you're starting a new idea or initiative. It tends to be very nonlinear. But to give you a sense, we started with this concept of idea generation, really thinking about both our passions, but also the pandemic, the moment in time, and some shifts in real estate. And then we moved directly to a lot of Zoom calls, calling people across the board, whether they were developers or cities, architects, general contractors, to get a sense, is this something that would actually be useful? Is this something people are really interested in, this kit of parts for adaptive reuse? And through those conversations, we were really able to refine, what kinds of buildings would be best for this use case, what should we include in our kit? And along with what needs to be included, that obviously led to chatting with some manufacturers, getting a sense of how much things would cost, and then, really developing from all of those a product. And that's where we are at right now, is this stage of prototyping and eventually leading up to, in the next few months, building a unit as proof of concept. So hopefully that gives you a bit of a sense of, the entrepreneurship process. What's coming up afterwards would be fundraising and actually launching. And that's something that we've been exploring and thinking about. So definitely welcome more questions there. But I'd love to talk also about what entrepreneurship might look like or might mean for students, because we started this as graduate students at Stanford. And I think one dimension that was unique about entrepreneurship as students was what initially brought us together. Initially we got to know each other as friends in the same graduate program, and we found through different projects, different events, that we really enjoyed working together as a team. And so I think it was unique in that sense because the academic environment enabled us to meet around shared values of sustainable housing justice, and we had opportunities to develop our teamwork before KidSwitch. And another unique dimension of entrepreneurship as students was the fact that we were able to benefit from competitions, funds, and organizations out there that are specifically designed to elevate the ideas of students. And these were absolutely instrumental for our start. And finally, once we'd started working on KidSwitch, we also had the chance to organize some of our coursework around this passion project. So we used KidSwitch as a case study for some of our courses on production system modeling, which is where we got the numbers of, with all of the different processes, how many units, what is our throughput per week? And then a life cycle analysis, which gave you some of those really interesting graphs about carbon intensity and sustainability. And that was a great way to engage with what we were learning in the classroom in a way that felt exceedingly tangible and very fun. So this is effectively what brought us all the way through to prototyping today. And when I started off, I definitely saw many challenges associated with starting entrepreneurship as students, and those challenges definitely exist. But I think undeniably our status as students also gave us some incredible opportunities, which shaped where we're at today. So with that, I'd love to turn it over to questions and have a conversation with all of you as well.